The web browser is an untrusted delivery mechanism. It's like the Wild West. There's a lot of malicious people out there looking to exploit security vulnerabilities on your website. Our Jamstack applications need to be able to understand who our authenticated user is and what they can do. But if malicious users can steal a user session, an API access token, or tamper with the user information in the browser, how can we secure our Jamstack applications? Well, this is where the BFF or Backend for Frontend pattern is applicable. But there's a lot of information out there about the BFF, and much of it can be misleading or not help you reach the level of understanding you need to implement the pattern yourself. So today we're going to delve into the BFF pattern to show how it can address those security concerns I stated earlier. Good morning, good afternoon, or good evening, whenever it is that I find you, and welcome along to the channel. And if you're new here, well, where have you been? Because we discuss all sorts of interesting stuff. But today we are discussing the backend for front end. And I think one of the fundamental aspects of the backend for front end that people overlook is the security aspect. So let's dive in and see what our website user has to do in order to log into our website when we're using a backend for front end. So the component parts of our solution are that we have our proxy server, which is where all of our front end traffic goes to. So everything from the user's browser routes through the proxy server. We have our backend for front end, which is basically just an API that sits behind our proxy server and deals with all of our API calls that our browser application is sending. We have our Spa web server, which is where our single page application, so Nuxt, React, etc., gets served from. And then because this is around authentication, we have our OpenID Connect provider. So the journey that our user goes through for authenticating is that we essentially route the browser. So this is not an HTTP call from the browser. This is a routing call. So we redirect and navigate the user to the login of the BFF. So the browser gets navigated to that particular API. The processing of that API forwards that request back to the browser and asks for a redirect across to the OpenID Connect provider. So by the time the user gets to the OpenID Connect provider and they get presented with the page that prompts them to enter their credentials, then they have already been redirected a couple of times and they are now on a request that's sitting inside of the OpenID Connect provider. So once the user enters their credentials, the OpenID Connect provider makes a callback API call. So again, it redirects the user's browser and makes a call back to the BFF on the OpenID Connect callback. So whatever you've configured that to be. So in this example, it's /OIDC callback. The user's browser will call that particular API. So then inside the processing of that particular API, it's here where this has to then generate any mechanism that we're going to use for authenticating that particular user going forwards. So in our case, we are going to generate a cookie and we send that back to the user's browser and we redirect them back to our single page application with that cookie being created. So what that means is that the user's browser has then got that cookie so that any calls to our domain, our URL, will actually automatically send that cookie. Now we're setting that cookie up as a same site cookie, so it should avoid some of those headaches around people hijacking our session, etc., but we'll get to some of that. So that's essentially what it means, is that we can make API calls now which are HTTP calls. So from our single page application, any fetch call, etc., is going across HTTP. It's going to attach that cookie to that request, and our backend for front end will receive that cookie, know that it's an authenticated request, and be able to process that request and send back the response back to the user's browser in a secure fashion. But there are a few kind of edge cases and concerns around these single site cookies. So it is possible for someone to hijack that cookie, as I say, and be able to send requests from that user's browser, and because it's coming from their browser, it's got the cookie. It will send that cookie along to your backend for front end, and to all intents and purposes it thinks it's the user that's doing that. So we can strengthen this up a little bit by attaching a custom header into those requests. And in attaching that custom header into those requests, it means that those requests are then subject to cause. It would mean that it would look more at the domain that's making that call before it attaches that cookie into that request, and it would be rejected because it's not coming from the same site, etc., etc. So we're just strengthening our security by adding in that additional header. But we can go a step further than that, and we can actually use CSRF tokens. So what happens with these is that your BFF will generate a token when it starts up, and your SPA application will actually make a request to go and get that anti-forgery token. And so then it stores that in the browser, and along with every single request that then goes to your backend for front end, we attach that cross-site request forgery token as a header. So that's the header there, the XSRF token. We attach that token into every API call that goes across. And when that token goes across with that API call, the API has to validate that that token is correct. So as well as validating the authentication cookie, it's also validating the cross-site request forgery token. So we've got two areas of security there that are being validated on every API call. So we're increasing the security of our API in doing this. And then also in terms of the whole point of introducing the backend for front end is so that we can get user information. So our backend for front end has done all the authentication, and it knows who the user is that's attached to that cookie. So how does the SPA application get hold of that user information so that it can make decisions around who that user is and what permissions that user has? So what we can do is we can allow our SPA to make a secure call to our backend for front end to get the user information, and we can make that kind of smart so that every time the SPA requests user information, it can maybe look to see how stale that user information is. So maybe refresh it every 60 seconds, 5 minutes, whatever your preference is, how old you're willing to let the user information get before you want to go and force refresh it. So what this means is if someone has tampered with that user information inside of the browser by some means, then eventually you will go back to the API to get a fresh set of information that you will then overwrite it, and you'll keep that browser session with relevant data, valid data that hasn't expired, hasn't been tampered with. And then the other benefit of having a BFF is that you can make subsequent calls to other APIs. So you're not making those calls directly from the user's browser. You are routing those calls back through your backend for front end. So every call from the user's browser goes to your backend for front end, using that secure cookie authentication to do that. But then you could have your backend for front end call to some other downstream API using JOT authentication or some other authentication mechanism that's different from the one that you're using for the browser. So it opens up all sorts of possibilities, and you're not exposing any of that security information out to the user's browser. It's all contained securely on your backend for front end server, and that can then obviously flow back to your user's browser with all of that information. So it's a way of securely accessing other APIs without exposing any additional security information to the user. And then the last thing that we obviously need to be able to do is to log the user back out. So the flow for this is very similar to the login. So it's not an HTTP call, it is a navigation to the API's logout. So we navigate the user to the logout function of our BFF, and as part of that processing, the BFF may choose to call the OpenID Connect provider. If you want to do single session logout and logout everywhere type functionality, you can make that kind of call. But essentially the BFF has to invalidate the cookies and send back that request that navigates them back to the SPA with those cookies that have been cleared out, so that the user is now no longer authenticated to call your BFF. So they're back to where they were originally before they logged in. So to support a BFF functionality, what we need is we need a login URL, we need a CSRF token, we need a user endpoint where we can go and get user information from, and we need a logout endpoint as well. So these are the 4 endpoints that we need to implement into our BFF to support all the things that I've just shown you. So what we're going to do now is jump over and we're going to create a Nuxt 3 front-end spa from scratch, and we're going to have that hook into these endpoints, and we're going to create a .NET based BFF for this spa application, and that BFF is going to call out to Azure B2C to do the authentication. So let's go and jump over and hook all this up and show you how it works. Okay, so here we are, and I've created myself a new folder, Nuxt 3 ASP.NET BFF. So the first thing that we're going to do is go and create ourselves a new backend. Let's cd into that backend and open that up in VS Code. And this is going to give us a minimal API. So I'm going to create the usual weather forecast bits and pieces. So right at the top here, I'm going to create just a variable for the summaries and put in the weather forecast. And let's add in the weather forecast object itself. Okay, and let's jump over to the launch settings. Let's just change this so that it's listening on 5010, and let's get rid of the server ready action, because we don't want a browser to launch every time we start our API. Then we need a terminal in here, and we're going to add the ASP.NET Core OpenID Connect package, and then we can start having a look at how we build some of this up. So before we do our app build, let's get some useful variables. So we'll get out the services, the configuration, and the environment. And then what we're going to go and do is add in the authentication. We go and add authentication into this API, and we say we've got 2 schemes at play here. We've got the cookie scheme, and we've also got the OIDC scheme. And it's important which one of these you set up. So the default sign-in is cookie, so that means we're going to be using cookie authentication by default. And then when we want to ask someone for their credentials, we use the OpenID Connect configuration. So let's go and add in underneath there the cookie information. So these are chained together. So we add in cookie, and that name is important. It ties up with the name that we've specified there. And then we tell it the type of options that we want our cookie to have. So how long it expires, so maybe a day of working before that cookie expires, but it is a session cookie, so it will expire when the browser gets closed. And these are obviously the important ones, the same site strict cookie setting, so that we're restricting it only to our site that will send this particular cookie through automatically from the browser. Then we can go and add in the OpenID Connect bits and pieces. So under here, add, and again the name is important, OIDC ties up to OIDC. The first property that we need in our OpenID Connect is the URL that we need to call. So this you can get out of the Azure portal information, and it's basically our tenant and our domain within the B2C, and then our flow, user flow essentially is what that maps to. So that's the basis of our authority that it will use, so the URL that it will call across to. And we're pulling all of that out of configuration, which we'll go and add in a minute. So then we need a client ID, a secret for the client, which will again we'll get from config. We need our basically our OpenID Connect flow and response type, so that's what that specifies. Our callback URL that we're going to use, or that we're going to tell B2C to call back on, and then just some options around what that particular OpenID Connect plugin should do with claims and etc., and whether it should save things. So that sets up our OpenID Connect provider, and I'm going to paste in a comment block here just for when I check this in. But essentially, if you want this to work with HTTP, so when your callback comes back on HTTP on localhost, you need to specify these additional options so that it sets up the cookies correctly. Otherwise, it just doesn't work. So, but I'm going to be setting up my front end on HTTPS, which means I don't need to do that, but I'll leave it in the repository for you if you need it. So then we've got some scopes that we need to specify. So we clear out all the current scopes. So that's our scopes all set up, and we can close that off. So that is all of our service configuration done for cookies and OpenID Connect. So the other service we need to add in is we want to say that we want authorization on this, because we need to authorize some of our endpoints. So we're going to do that. Then we can build our application. Then we need default files and static files, just so that we can deal with that kind of stuff inside of our BFF. Then we'll wire in authentication into the pipeline at that point, and we'll add in routing so that that works, so that we can use the map endpoints functionality. Then authorization, and finally the app use endpoints. And I can move this. Just need to fix that up so that says endpoints now. So we've got our weather forecast inside of using our endpoints. So let's go and add in to our app settings all of those settings. Again, all of these are coming from the Azure portal inside of my B2C instance. So this is all my application ID, etc., and the callback that I'm going to call back on, so /OIDC callback. So we'll need that in a bit. This is the user flow that I'm using, so a B2C sign in only flow, so I'm not allowing sign up. So let's go back over and add in our login endpoint. So above our weather forecast, the first endpoint that we'll have is our login one, and we want this one to be an anonymous call. So because we're not logged in, we have to allow everyone to be able to call our login. So API account login is our URL to log in. So what does this look like? So we are also accepting a return URL. So you can allow your Spa front end to call this with a return URL, and this will redirect you back once all the login is complete to that particular URL of your Spa application, is what that's for. So we need to be able to deal with that. So let's just look at that, and if it's empty, we return them to the root. Otherwise, we return them back to the return URL that you've specified. So that's just a nice to have that you can use. We then create a new authentication properties, and we pass that redirect URI into it so that it gets saved as it goes round the whole round trip of the OpenID Connect dance. And then the last thing that we need to do is instruct ASP.NET to perform a challenge using those properties. So that's what kicks off the whole OpenID Connect aspect, is this challenge async. If you remember, we specified that OpenID Connect was our default challenge scheme, and that will do us for our back end. So let's run that up, jump back over to our terminal, and let's create our Nuxt front end. So npx nuxi front end. Okay, let's open that up in VS Code as well, and we need to get this enabled with HTTPS. So I've got a development key and certificate that I've copied into here, and I've got a video on how to set up Nuxt with HTTPS, so I'll put a link to that above. But what we do is we change the dev settings so that we set node to ignore certificate problems, and then we start Nuxt on HTTPS using that dev cert and key. So that will give us HTTPS. Then I'm just going to go into the app view, and for now I'm going to paste in just an anchor to that API login. So as we said, it's a navigation, not an HTTP call. And then another thing that we need to do is come into our Nuxt config, because we need to set up the proxy. So in my diagrams, I had a proxy application or server sitting in front of my API and my SPA. So because I'm only doing this on dev, we can utilize the Nitro proxy for this. So I can plug in the Nitro dev proxy, and any routes that go across to API go automatically across to 5010/API. Anything that comes in on that OpenID Connect callback will also call across to my API, but on OpenID Connect callback. So that's essentially doing what the proxy server would do. So if you were using something like YARP in front of your SPA and API, then you would have to put these routes into the YARP configuration so that they get forwarded accordingly. But as we're running in development, we can just use the Nitro dev proxy here. So now we can run this up. And if we open a browser to our localhost 3000, we get our site up and running. So if we bring up the dev tools, we can go and have a look at the cookies for this site, and we can see we don't have any cookies at the moment. Let's bring up the network tab and just see what happens here. So we click the login, that's doing a redirect across, and then calling our Azure B2C, doing another redirect. So we need to enter our credentials that we've set up in our Azure B2C, and then when we sign in, we come back eventually to our site. Let's just see if we can find the various different bits and pieces here. So it's called back here on our OIDC callback and given us our state and everything else that we get with our OpenID Connect callback that we would expect. And if we jump over here, we can see that we've now got our session cookies that ASP.NET is setting up for us. And these are session cookies, and they're HTTP only, and they're same site strict, etc., etc. So they are very secure cookies that will only be sent if we send them from our particular SPA front end on HTTPS localhost 3000. So that's the login dance done. That's the difficult bit, really. So let's jump back over and let's add a log out. So in here, underneath our login, let's add a log out. And for this one, we want to require authorization. And we can see in here that as part of the logout, we also can specify a redirect URL where we want that to go once it's done its funky thing. So let's interrogate that, and if we don't specify one, we just route back to the root of the site, which is good enough in our case for this demonstration. And then we do our sign out on the cookie authentication. So we're allowing ASP.NET to tidy itself up, and we also do a sign out using the redirect so that it redirects back off after it's done it. So let's save that and fire that back up again, jump back over to the front end, and in our app view just underneath our login, put a break, and let's specify a logout. And we can come back over to our browser. We've got our login and log out. So now if I hit log out, calls across to our API, does the logout, clears all our cookies out as we saw there, and then redirects back to our site as we would expect. So that's all working. So that's login and logout. So now let's look at the user info endpoint. So I'm going to add a new file in here called claim value, or in my case calim value because I can't type. And claim value is just a simple name value pair class, nothing more sinister than that. And we're also going to have a user info class, and inside of that user info class is where we're going to use that claim value. So the user info represents everything that we know about this particular user from what our OpenID Connect provider has told us. So we've got the entire list of claims here and the role claim type. So which of these claims is the role, which of these claim types is the name that we want to use. So let's go and add the user endpoint that we need. So we are listening on API account user for this one. And again, we need the user to be logged in before we grant them access to this particular API function. So in here, we're going to get hold of the user, the authenticated user, which we get out of the HTTP context. And we're going to set up a new user info and hard code our name and role claim types where we get those from. We're going to check if the user has any claims or not. And if they do, we're going to do something. And then last but not least, we are going to return that user info, but we first need to tease out the name claim. So we get all the claims that match the name claim type. We select those as a list and we add all of those claims into our user info object. Then we do something very similar with the roles. We get the extension user permissions claims out of our token and we remap those across to the role type, and then we add those claims. So let's run this up and see what that gives us. So if I log in again, then when I come back round, I can go to /API/account/user, and I can see that my user his name is administrator, and he's got two roles of user and admin. So that's the useful information that I need for my particular SPA. So you can add as much or as little information as your front end needs in the user information. So that gives us our user info. So let's go and look at adding in cross-site request forgery. So let's jump back over to our API, or our BFF in this case. And up at the top where we're adding our services, we're going to add in the anti-forgery service, and we're going to give it its custom header name that we want it to use and the cookie that it uses. And again, it's same site strict for all of that. So that sets up how we want the anti-forgery to work. So let's go and add in the endpoint where we're going to get our anti-forgery token from. And again, this is going to be an allow anonymous because we want our SPA to do this at startup. So we get from the services, the anti-forgery options and the anti-forgery service and the context. So what do we actually need to do here? So using the forgery service, we can get hold of the tokens. So this will generate us a new one if there isn't already one and give us that back. And then we can create our cookie in our response. So we get hold of the response from the HTTP context, create the name of our cookie that we want, and we append the token into that using all the same site, HTTP, etc., etc. So now if we go and correct our user endpoint to cater for this anti-forgery, we need to add in the anti-forgery service in there. And the first thing that we're going to do is the anti-forgery check before we do anything to make sure that that matches. So we're going to create a new method in a minute called validate anti-forgery token, and if that fails it will return a bad request. So let's go and create that method, and it takes the HTTP context and the forgery service, and we're going to have a try catch in here. And so all we're going to do is we are going to await for the forgery service, validate request async, and give it the context. So that will validate our anti-forgery token, and if that's the case we return true from here, and if that throws an anti-forgery validation exception, then we just return false to say that it failed. So that gives us our anti-forgery. Now when I run this up, that user call will fail because the anti-forgery doesn't work. I get anti-forgery token validation failed, as we would expect, because I'm not sending in the anti-forgery token with my request. So it shows that we are tightening up our security. I now need additional stuff to be able to call that. I can't just rely on the browser to forward that authentication cookie. I have to do some more work for my API calls to work. So let's jump back over to the front end and tidy some of this up so that we can make this work in a nice clean fashion. So we're going to need a couple of packages. I'm going to add Pinya into this. And we're also going to need the Nuxt Pinya module as well. So then we can create a new file in the store folder. We'll call it account. So we'll import a couple of things into this from Pinya and from Nuxt. We're going to define it as a plugin, and the reason we're going to do that is because at startup I want my Nuxt app to query for the CSRF token. So that's why I'm defining this as a plugin. So because I'm doing that, over in the Nuxt config, I need to go and add the store into the plugins. And while we're here, we will also add Pinya as a module. So that will do that. So now that means that this will run at startup. So inside of this startup code, I want, if it's client side only, then we get hold of the account store, which we're going to define further down in this file. And we then make a call to our API endpoint to get the anti-forgery token. And once that call has worked, then we've got our cookie. So we can get hold of our cookies, and we need to split the cookies down. This is just how it all works inside of the browser. We need to split them out. They are semicolon space delimited, the cookies, so this will give you all of them. And then we are going to find our CSRF cookie, which is the one with that name that we've specified inside of our BFF. And so we get hold of that, and we get hold of the value from it. So that is what our token value looks like. So therefore we can then check if we've got that token and it's not empty, then we're going to set that into our account store in the state in the anti-forgery token. So we're going to hang on to it inside of our account store that we are going to define right now. So to define our store, we need just a couple of objects. So we've got our user info object, which any part of our application can get out and get hold of the name of the current logged in user and the array of their roles that they have. So this would make it easy for us to do some permission checking to allow people that are either authenticated. If this comes back empty, it means they're not logged in, but we've also got a flag that will tell us that anyway, but it also gives them the permissions that they have, so we can set up some extra stuff inside our app if we want to check that they have certain permissions or not. So let's define our account store, and we'll set the state up. So the state is going to be our account store state, so we hold on to the anti-forgery token, the current user info, the time that the user info was last retrieved from the BFF, and a flag that states whether or not we have logged in or not. So we set all those to some default values, and then we'll have some actions. So inside of our actions, we'll have our user info action, which returns us a user info or null, and we'll come back and fill that in a minute. We'll also have our is logged in flag. We just need an asynchronous call to say go and get the user info, and if we get the user info, then we set the flag to say that you are logged in. Underneath the actions, we've got our getters. So in our getters, we can just get hold of the anti-forgery token so that this is available across our app. So we just get that out of the state. So that's fine. So let's go and have a look at the user info bit. So let's create a constant up here for our threshold, after which we want to refresh and go and make an API call. So if you make 2 calls within 60 seconds to get the user info, there's only going to be 1 API call across to your BFF, essentially, is what this is doing. It's trying to make it efficient so that you only get it when you actually need to go and get it, which is what this bit of code I'm adding in now does. So it checks if the user info last retrieved is null, or it's more than 60 seconds ago that you retrieved it, then you will go and get it again. The first thing that we do if we need to actually go and get it is to refresh that timestamp. So we set that this was when we last retrieved the user information, and then we will call or try to call the API, and let's do the error handling side of it first. So if we get any exceptions being thrown, then we just set the is logged in to false. Then we need to actually go and add our call to our endpoint. So we call account user, and we're introducing a composable here that we're going to go and create in a minute so that it makes calling to our API easy and consistent. Because remember, to call this, we need to add in our cross-site request forgery token, so we don't want to have to embed that everywhere, so we'll do that in a composable. So we'll do that in a minute. And once we've made our call, then we can go and look at the result that comes back, which, if you remember, is our user info, and we can find out the name claim and the role claims, and we can populate that into our names and roles inside of our user info object. And the last thing we need to do is, if the API call is successful, is to set the logged in flag to true. As is usually the case, we return this .userinfo out of this call, so that when you call it, you actually get the user info back or null. We've introduced a composable there, so we need to go and create that composable as well. So that's the next piece in the puzzle. Let's go and add a new file in the composables folder called call API, and we've got a couple of imports. So fetch to give us the fetch options, and we're also going to import that store that we just created from the account store, and that's because we need the anti-forgery token. We have a couple of constants, one that represents what our prefix is for our API, so it will prefix all of those. So if I just jump back over, you can see that I only specified account and user, so the composable will prepend API onto the URL. And this is the anti-forgery token header that we're going to send in, that we're going to use when we actually make the call back to the API. So that's the header that the API is expecting our cross-site request forgery token to be on. So we're going to export just some options for people that are calling this interface within our app, and we're going to have a method on those particular options, and that's so that they can specify what the HTTP verb is that they want for this particular call. So let's paste in what our call API composable looks like. So as I said, it takes a partial version of those options, and it also takes the path. So we're going to get hold of our store, and we will set the method inside, and we'll default it to a get method, but you can override it from the options. So we'll set up the fetch options object that we're going to pass to our fetch operation, and we'll set that up with some defaults. So the base URL is going to be the API prefix. We do want credentials to go across. We will set the method, the HTTP verb, to be the method that we've defined above, and then we'll pass in our custom headers. So into the headers collection goes the name of the anti-forgery token header, which is this one, and the value of that header is going to be what we get from our account store from the anti-forgery token. So what we've queried from our API basically, and teased out of the cookie that it gave us back. So that's our options defined. Then all we need to do is actually make a fetch call to that path using those options. So that gives us our composable that will call our API for us. So now we can use that composable all over our application, and it will automatically append in the anti-forgery token that we've stored inside of our account store. So let's just tidy up our login and everything, because at the moment we've just got these hard-coded anchor tags in here. So let's go and tidy this up a little bit as well while we're here. So let's create a new file in components called account.view, and I'm just going to copy in the whole template. So basically it's going to check a variable that says, are we logged in? If we are not logged in, it's going to show a login. If we are logged in, it's going to say hello with a username, and it's going to show us our logout prompt. So now we need the scripting to support that. So we've got our script set up, and we're importing our account store and user info. So using our account store and setting up those two values as reference variables with default values. So by default we're logged out. Then what we can do is put a watch on the account store is logged in value, and so when that calls this method, it means it's changed. So we can get and set the value of is logged in. So this value up here is set to the value that's passed in. So if that's logging in or logging out, that will get set accordingly. And if it's been set to true, then we get the account store user info and we get the name out of it, and we set it to empty string if we can't get hold of that for whatever reason. So that's what our account view does. So now over here I can get rid of all of that, just change that to my nice clean account component. So let's give this a run up, and we've got some errors. Just fix that up. How we missed that, but there we go. So let's jump over. We can see our login, and if I go and actually log in, then I'm missing the name. Let's just bring up the dev tools to show you how we might debug some of this. So we can go into the view tools and we can see our username is empty. So let's just go and jump over and have a look at our account store user info, and inside of the if block, if we're okay, that just needs to be outside of that block so that we always return the user info. So let's jump back over. There we go. So now we get hello, and the name is now populated as we would expect, and we can call our logout function, which calls our logout, kills off all our cookies, and we're good. So what we can do as one final exercise is to come back over to our API and just add in validation to our weather forecast so that we validate that as an anti-forgery token. And incidentally, in .NET 7 we don't need to be doing it this particular way where we have a method to validate our anti-forgery. You can do filters now with minimal APIs, so you could have a filter in here like validate anti-forgery or something like that, and then require authorization. But I'm not going to do that here because this also works with .NET 6. So let's just take our anti-forgery token, come down to weather forecast, and inside of our weather forecast we will also validate our anti-forgery. And because of that, we now need to accept the HTTP context and the forgery service. We need that injected in. So this is where filters would probably be a better option, because then you don't have to take those dependencies. We just need to wrap this with a results. Okay, so that is happy. And now we're validating our anti-forgery token, doing our functionality if that's okay. So we can run that back up, and then we can just jump over to our front end inside components. Let's create a weather forecast.view, and let's just dump out whatever we get back from the weather forecast API. So let's have a script set up underneath that. Let's import our account store. So much like we did in the other one, we just have some variables. So we've got our account store, we've got an is logged in, and we've got our forecast data that's set up as a reference variable. And then we'll add in a watch method like we did before. So we're watching for the is logged in value, and we will set our local is logged in value to whatever gets passed in here, so true or false. But if the value is true, so we are logged in, we will do something else. We will do something else. So the something else we'll do is set the forecast data value to an empty string. But if we are logged in, then we can make a call to the API weather forecast and set the forecast data value to the response of that. So then all I need to do is come over to the app view, and underneath my account add in my weather forecast component, save that, come over here, let's log in, and we get our weather forecast being called. So let's just go and look at the network tab, and we can see our weather forecast is called. And in the request headers, if I come right down to the bottom of the request headers, you'll see that we're passing in our cross-site request forgery token with the value that we extracted out of the cookie. So it was a bit of a long one, this one, but if you made it this far, well, thanks for sticking with it. That is our Nuxt application up and running with an ASP.NET based BFF. So let me know in the comments if you found this useful. Also, if you did find this useful, then please do like and subscribe to the channel, because there's more like this coming, and it does help me out an awful lot if you do that, and it helps these videos find more people. So with that, I just need to thank my channel sponsors, and with that, I will see you in the next video. Thanks for watching.